jumping into book questions. I have got, well, there will be once you see them all, 7 issues on here that would either be a permutation or a combination. I don't care if we don't figure out exactly what the answer is, but we do need to take a peek and see if we can tell the difference. So, if we are going to dinner and a movie, and there are 5 restaurants and 7 movies to pick from, is that a permutation or is that a combination? They're like it's a okay, think of it this way. If I went to Applebee's and then the Life of Pi, or then I went to the Life of Pi and Applebee's, is that the same thing?
Yes.
Okay. So in that case, then order wouldn't matter.
Permutation.
In that case, order wouldn't matter, so it'd be a combination. Okay. Now, if you were actually going to calculate that, though, instead of having to go through a whole bunch, because you've got 2 separate things going on here, if you were going to go to the calculator using, you know, what you can in there, you'd have a combination of 5 restaurants, pick 1, and a combination of 7 movies, pick 1. That's the longer way to look at it. If we just want to use common sense, we go, well, I'm going to dinner and I'm going to a movie. There's 5 picks for dinner and there's 7 picks for a movie, and I just multiply them together. These will get me the same thing. I don't care which way you do it. If you can look at it with common sense and make it work, then do it with common sense and make it work. Okay? But if you want to do it with the other things, you can. So what about 2? We got 3 dental appointments for 10 patients. 10 patients have a toothache, but I only got 3 appointments available right now.
Well, that's not going to have any permutations.
Yeah, that's not going to help a whole lot, is it? There's going to be 7 unhappy people. But beyond that, to me, does the order I take them in...
Sorry, sir.
make any difference? No, because I'm still going to see those patients. It just depends on the order that I take them. So again, we'd be looking at a combination type thing. And so you just kind of keep thinking, you're like, okay, I kind of see maybe, hopefully, where this is going. Putting 4 novels and 5 autobiographies on a shelf.
This order, so it does kind of matter.
So if I'm looking at the shelf and I've got like the Scarlet Letter and then Hunger Games, or Hunger Games then the Scarlet Letter,
What is combination?
does it matter?
It depends if you're at a library.
If they're just on your own shelf,
Then it's
No, it doesn't matter.
combination.
no, it doesn't matter. Okay. Like, dang, are these all going to be combinations? No.
Yeah.
No.
No.
Okay. Select a committee of 2 boys and 2 girls from a group of 3 boys and 4 girls. Yeah. Because if I pick Ben and Jack or Jack and Ben, again, doesn't matter in this case.
Yeah.
It will sometime, but it doesn't right now. But select a president and vice president from a group of 10 students.
Permutation.
So it doesn't matter who the president and who the vice president is?
Yup. Don't matter.
Well,
You just got pickle.
It doesn't matter. So like right now, if you had President Obama and Joe Biden, it doesn't matter which one's which. We can move them interchangeably with each other.
Yep. Just kill Obama, though.
Oh, I'm frightened with some of you. Okay.
It's a
Permutation.
That's what I said.
To rewind. Watch it.
Ah, I didn't like.
Okay. Making a security code of 3 letters and 2 digits.
Permutation.
Yeah, order definitely matters on that.
No, it doesn't.
Yeah. Oh, yeah. Determining which of 5 students wins first, second, and third place.
Order matters.
That is a permutation because it matters on if you get first, second, or third. Are you getting okay. But you kind of start to see how this can work. Now, all right, I'm already hearing. Which one do we need to take a peek at?
Well, I got one.
So what do we need to take a look at? Which ones?
What?
So basically the story problems. Okay.
Page number 28.
So let's take a peek at what we've got working here. Let's do this. At least we can make this work a little bit better. Okay, so basically the story problems. Let's see what's going on here. Decide whether the problem requires combinations or permutations, then solve the problem. Okay, 55. 8 members of a school marching band are auditioning for 3 drum major positions. In how many ways can the students be chosen? Okay. No, we cannot trade books. The only time I break this out is just I'm looking for it for problems. I do all the homework assignments with a student book because I don't want to just stare at this thing. Yes, keep my brain fresh. So let's see. Now, again, let's not think so much. I mean, first, 3 drum major positions. It's not like it's 3 separate positions. They're all going to be drum majors. So that's how we know right away that it's a combination. Now again, if you've got the calculator option, and you can say, okay, there's 8 people, I'm choosing 3. That's an option.
I always have trouble finding numbers for that.
And again, with combinations, it's the factorial of our number of choices.
Divided by the number of our choices minus 3. And then factor 3.
Uh-huh.
Wait, don't you have the factorial?
I don't know. I'm waiting to see, because this is one of the things with some of you I want to make sure we've got a grip on. So, while we're doing this, oh, can I get this page to turn over the way I want? Not quite. What one part am I missing right now?
Factorial 3?
Yep. Because whenever you have a combination, the 2 factorials that you get in the denominator are going to add up to the one that's in your numerator. If it was a permutation, it would just be the 8 minus 3. And that's the difference. Whenever you're working with a combination, you're actually going to get fewer choices, or a smaller answer, I guess we'll say, because you can have things that repeat. So, if I wanted to type it into my calculator and I had factorials, I can do that. If not, we talked before about multiplying down to the largest factorial we see in the denominator. So we could cancel those. And the difference is going to be, if I'd have done permutation, it just would have been the 8 times 7 times 6. I'd have gotten a larger answer. But in this case, it's not. So what we will do is take a quick moment and get our answer, which in this case would be 56. Much smaller than if I'd have just done 8 times 7 times 6. That's the thing that I've got to be cautious of.
Wait, what's...
So, if I'm looking down then, let's say at 56.
Isn't 8 times 7?
Yes, 8 times 7 is 56.
Why'd you say 8 times 7?
Because, again, okay, let's flip back to here for a minute. Because here, let me make sure I got your question right. Your question again was?
8 times 7 times 6 is not 56.
That's true.
Oh, but then you divide it. You didn't say the divided part.
Well,
Well, I mean, I was paying attention, but...
So, your yearbook has an editor-in-chief and an assistant editor-in-chief. The staff of the yearbook has 15 students. How many ways can you choose? Now again, editor-in-chief, assistant, 2 different positions. So that's how I know here that it would be a permutation. Now, this one, again, I've got options, but for some of you, it's probably a good idea to stick with the, okay, 15, choose 2, instead of just doing 15 times 14, which is what you're going to see happen here in a minute. Because remember, with permutations, I'm still going to subtract my two values, but instead of like with combinations where I then add the extra one in, I don't here. So right now I have 15 factorial over 13 factorial. But whenever I have a permutation, I'll end up wiping out the denominator. Those guys wipe, and I just multiply 15 times 14, which is 210.
So you only have to put 3 numbers?
Well, you only have to go to the bottom, the denominator.
Yeah, you go as far as whatever this factorial is.
Only for permutations.
So, for permutations, right. It'll cancel out for me. That's why it's good for me to understand the general idea with permutations and combinations, how the general form works. For instance, just out of curiosity, you know, what would be the difference between combination 15 pick 2 and, oops, and permutation 15 pick 2? Well, we just did permutation, which would be 15 factorial over 15 minus 2 factorial. So we worked that out, and again, we just start working down until we get the factorial at the bottom, cancel, and get our answer. If it were combination, if we just said we're going to have, you know, 2 editors, okay, 2 editor-in-chiefs, they're not going to be any different. That would have been combination. My numerator would be the same, and I'd still do the 15 minus 2 factorial, but then I also would do 2 factorial. Because when we have a combination, my factorials are always going to add up to the one that's in the numerator, because there's actually going to be less choices because they're interchangeable. So I still would work this out the same way. But now when I do my 15 times 14 and get 210, I've got this 2 I divided by this time. So in this case, not every time, in this case, the combinations would give me half as many choices. Because if I had editors, again, I could take, you know, any 2 people, and they'd be interchangeable. It wouldn't be any specific order, so I'd have half as many options. But understanding this setup, because I can do this with a calculator or not, whether I have this or whether I have this, but it kind of gets me into one of those situations where I don't want to be, where I think it's just multiplying the individual parts every time, because it's not, it depends on if it's a permutation or combination. So that's how those work. You've got to know that part right away. So if you're still getting stuck on 57 and 58, relay race has 4 runners who are on different parts of the race. 16 students on the team. How many ways can your coach select students to compete in the race? So again, those parts are going to make a difference. So that's why this one ends up being a permutation. I wish they'd have said different parts as in, you know, same distance, different distances, what, where you could kind of get into an argument there. Or again, you must take 6 elective classes to meet your requirements. There are 12 classes you're interested in. Again, I can take those 6 classes in any order I want to, as long as I get all of them. So that's why that one's a combination and sets up differently. But the general way that these set up still would be this, which is why you have to understand the formulas that go with combinations that these two have to add up, or permutations where your value on the top is always going to be greater than your factorial on the bottom. Any others, like from the worksheet or anything we want to take a peek at? On the worksheet. Okay, what on the worksheet? 2 and 3. 2 and 3. All right, let's move this out of the way. Thank you. All right, let's see what's happening here. 2 and 3 on which side?
83.
82.
Oh, geez. All right, so 83. Let me grab a sheet here real quick.
Yeah. It's in there. What? You want it out?
All right, so on 83, we've got 10 dogs. So number 2, How many of the possible selections do not include Elmer or Una?
Una.
So we notice up here we got to choose 2 dogs to take to the show. So normally there'd be 10 available, but if I don't include Elmer or Una, how many choices do I have?
8.
Okay, I have 8 choices. But here, when I'm looking and I've got the combination, my order doesn't matter. So like for instance, if I can't use those 2, if I pick Rusty and Elmer, Elmer and Rusty, it's the same thing. So it'd be a combination in this case of 8, since I can't choose Elmer or Una, choose 2. So if we could get that set up, then again, whether or not I have the calculator buttons to hit really doesn't become a big deal, because I know with a combination, 8 minus 2 is 6. Copy the second one, because these are always going to add up to the one on top.
Who wants to do that?
Well, people that may not have one of these available. That may be. So 56 divided by 2 is 28. Now 3 gets a little more complex, but that's why the hint's there. How many possible selections include either Harpo or Henrietta or Sylvester? Hint, find the number of selections that include none of these dogs, then subtract. Okay, well at first, my total number of combinations that I figured out number 1 would be all 10 dogs available, pick 2. So let's say I pop that into the calculator. We'll kind of go back and forth here on our methodology. So I've got 10, choose 2. Okay, so that's 45. But now I need to find out how many selections include none of those 3. Well, if I can't choose those 3, how many do I have left to pick from? 7. So I'd have pick 7, pick 2. So I'm going to take every combination, subtract the ones that aren't available for those 3, and that's going to tell me how many those 3 would be in. So 7, choose 2, would be 21. Would mean there would be 24 of the combinations if I were to write every single one out that would include one of those 3. Okay, not necessarily both, but it could be both, or it just might be one of those. So that's how you've got to watch for those. Occasionally you may have to add or subtract something. It does happen. Others.
Yeah, 83.
Okay.
How would you like start the first round? Because it says how many different stickers are there?
On 82.
Yeah.
Okay.
Same difference, same worksheet.
Okay, so 82, if I'm looking at those ones up top, they're just restricting what I have. Like for instance, if they just came up and said, how many different dinners are available? Well, I'd do 6 times 7 times 4 times 5, because I'd have pick one from each. Well here, how many different dinners are there that start with chili? So if I'm looking at it that way, I get an entree, I get a salad, I get a beverage, and I get a dessert. How many dinners are available that start with chili? Well, if you're telling me I'm starting with chili, you know, I only have one choice. It's chili in the entree round. But for my dressing on my salad, I still have 7 picks. And for my beverage, I still have 4. And for my dessert, I still have 5.
So you do the same thing on the next one that goes in the
Correct. The only difference would be now my beverage would be the one.
Yeah, that would be one.
Yep.
I'm just trying to confuse you.
Absolutely. That is my sole goal in life, is to confuse all of you. Others. Okay. what I'll have you do, and again, just reminders, the page 7, 12, and 82, 83, today or tomorrow, still deemed on time. Work on the packet that you picked up today. Again, it's just a mixture of permutations and combinations. We'll go over the answers to that tomorrow, and then we are going to start the ever popular experimental and observational studies. Basically, it's just figuring out where your problem is coming from, what type of problem it is. It's very quick. It's just, you're not doing a lot of math, you're just making decisions on, you know, yeah, you're just making decisions on types.
What are we doing in here Monday? Watching videos of that?
No.